In this example, we are looking at hydrogen lines corresponding to transitions from n equals 2 to 1 and from 3 to 2. So the first part of this was just deciding if it corresponds to absorbing or emitting a photon. And since we're going from higher to lower, from 2 to 1, 3 to 2, that means we're dropping energy levels. So we're losing energy. Losing energy must go into the form of a photon. So we're emitting a photon in this case. Going up in level, so if we went from 1 to 2 and from 2 to 3, that would require the atom or the electron absorbing a photon to gain energy to jump up. So in this case, we're emitting a photon. So what we want to do is figure out how much energy that photon has and then convert that to a wavelength. So we're using the change in energy formula from the Bohr-Rutherford model. That change in energy we can relate to the wavelength using the de Broglie relation. And the change in energy, according to the Bohr-Rutherford model, is 13.6 electron volts times 1 over n1 squared. n1 is where it starts, minus 1 over n2 squared. n2 is where it ends up. So going from 2 to 1, we plug in n equal 2 for n1, and n2 is 1. So this quantity is minus 3 over 4 when you work it out. Multiply that by the 13.6 and you get negative 10.2 electron volts. So going from 2 to 1, you lose 10.2 electron volts. So we want to convert that into a wavelength. So now we relate the wavelength to the energy, and we want this to come out in meters or nanometers. So this needs to go into joules. So H is this number, C is this number, and then 10.2 electron volts is this many joules. So when we work this out, you should find 122 nanometers. So that wavelength of the photon that is emitted when the electron jumps from level 2 to level 1 has a wavelength of 122 nanometers. Going from 3 to 2, the work is identical, except for now we're starting out at level 3 and ending up in level 2. So instead of being 3/4, this turns out to be minus 5 over 36. And the the photon's energy is 1.89 electron volts. So going from 3 to 2 is actually, if you compare it, a smaller amount of energy. So 2 to 1, the photon is 10 electron volts. From 3 to 2, it only is about 2 electron volts. So much smaller energy, and that's going to mean when you do the wavelength calculation, you get a longer wavelength. And the wavelength in this case, using these numbers, is 658 nanometers.